Hello everybody and welcome to the very first meeting of SECA, the Space Exploration and Human Colonization Association. We're welcomed by me, Ben Leposki.
I'm Justin Craig.
I'm Joseph Higgins.
I'm Trevor Brown.
Thank you everybody for joining us. We're going to be answering three main questions of our two planets that we're headed to, Kepler-22b and of course Mars, our next door neighbor. First question is, how is this planet suitable? What are the problems we're going to take together and what are the risks and rewards of going to that planet? First of all, we're going to be answering the very first question, how is this planet suitable, and I will be answering this. Now, this planet is a very dangerous planet to go to because it's 95% carbon dioxide. The average temperatures range from around minus 60 degrees Celsius because it's so far away from the sun. But this planet is very good for the mental part of the brain because it has an average day of 24 hours and 37 minutes compared to Earth's 23 hours and 56 minutes. So this would not affect the actual human brain because it's so close to the actual time. There is frozen ice suspected to be on the planet, so if we are able to melt this somehow, we can reach it and maybe even get oxygen from the actual water by creating new technologies. Now, Kepler-22b, being 600 light years away from Earth, is going to be very, very difficult to get there. So how is this planet suitable?
Okay, well, Kepler-22b, as we all know, is very far away from Earth. It's a lot farther than Mars, which is our neighboring planet. And Kepler-22b is very sustainable. It orbits Kepler-22, which is the system star, which is the same distance from approximately Earth to our Sun as Kepler-22b is to Kepler-22. So that's one characteristic that is very good for sustaining life. Additionally, the average surface temperature on Kepler-22b is approximately 22 degrees Celsius, which would be a mild summer day that Earth would feature. So additionally, Kepler-22b has a 290-day rotisserie cycle compared to Earth's 365-day rotation. So it's a little bit shorter, but it also features a similar effect that Earth does. And furthermore, just in comparison, or Kepler-22b rather, is approximately 7.9 times the size of Earth. So it has a larger geographical scale, which will allow for more highly populated and dense society.
Yeah. So there are many problems of getting to these two planets that we would have to invent new technologies. And of course, Mars, it takes roughly around 300 days to get to that planet. So how are we going to invent new technologies to get there and stay there, Justin?
Although Kepler-22b is the highest possibility for human colonization, we have to remember it's 600 light years away from Earth. If humans want...
So it's not even recording.
If humans want to live on a different planet, our answer may be right next to us. We found that Mars is similar to Earth a long time ago. Therefore, the easiest planet to terraform in our solar system. A process of changing a planet to a place where humans live. That's not about travel.
What? Yes, of course. When we go there, we're going to have big problems that we need to invent new technology. So keep going on first.
Well, we've decided that the best and most logical method is to add fluorocarbons into the atmosphere, trapping and absorbing sunlight. As Mars slowly warms up, the ice is trapping the planet's available carbon dioxide. We thought the release of the carbon dioxide in the atmosphere should produce a greenhouse gas effect and therefore warm up the planet.
And that's what we want, because if we warm up the planet, then we can maybe someday live on the planet without actually having to wear spacesuits.
Indeed. It is also, and after we warm up the planet, what we're thinking is that we could grow plants and stuff and get oxygen into the atmosphere so we can actually breathe.
And then, of course, Kepler, again, being 600 light years away, what kind of new technologies do we have to invent for us to actually get there?
So first of all, we don't really So 600 light years is going to take a very long time, obviously. So
Yeah.
first of all, we need a technological advancement to allow us to travel at faster than the speed of light, which would allow us to get there much quicker and save lives on Earth, or allow time to go by a lot slower. As well as, so since we don't really know much about Kepler so far, we have to bring lots of oxygen along, as we don't know whether or not, like, what air, like what gas is in their atmosphere. And we would also have to, we won't have to worry about the temperature of the planet, as it's, like Joey said, is at a nice 22 degrees Celsius. However, we might have to worry about a difference in gravitational pull and all, because we don't really know.
It's a super Earth.
Of course, yeah. We don't exactly know what it's going to do to the human body, if it's more gravity or less gravity, and how it can affect us. So we're going to ensure, by putting us closer to the equator and at a lower altitude, we'll be able to have less of a gravitational effect on us, to make sure that it's closest to Earth as possible.
Yeah.
And then for liquid, we could bring back backup supplies of water, and then just in case the water on that planet is not actually H2O, so in case it's not edible, basically. And then we can also figure out, using the water cycle, we can supply ourselves with pretty much unlimited liquid to drink. So that's what we have right now.
So, being that these two planets are extremely different, there are many risks and rewards of heading to them, and what kind of the kind of differences that we can, like, for example, new technologies that we can invent and all that kind of stuff. So Mars, so there was a test done near the University of Phoenix called Biosphere 2, where they tested the Martian soil against terraforming. And one thing we would like to do when we go there is terraform, so one day we can actually live there without having to wear spacesuits and that kind of thing. So in Biosphere 2, the terraforming project actually failed due to chemical reactions in the concrete. So because of this, we've learned many, many different things, and that is a risk when we go there. But a reward may be that the liquid ice won't be so difficult to filter, and it actually won't be so difficult. But it melt. But it may be. We know now. So the sooner we start exploring, the sooner the risks and rewards come to us. And Kepler 22b is very different. So what kind of risks and rewards would come from that?
Okay, well, as with any space expedition, there's always going to be their risks and rewards, as Ben explained with Mars. And seeing as Mars is just our neighboring planet, traveling to a different solar system has a new range of possibilities, both positive and negative. So, for instance, as Kepler is in the habitable zone of Kepler 22 is orbit, it holds great potential to be a planet similar to Earth. So, but we have to be prepared, as Trevor was saying earlier, with a steady oxygen supply, as well as food and all the other resources that we'll be needing. So yeah, there's definitely a great amount of risks that we'll be having to take as a civilization.
In the case of Kepler 22b, the biggest risk is probably going to be getting there, because it's like 600 light years away.
600 light years away. Is it possible that we can put humans into a hibernation mode, or would we have to continually create a new generation while they're on a spaceship?
Well, as our technology sits right now, the higher possibility is that we will have to sustain a civilization for approximately 23 million years, which is a lot of generations, and we'll have to create a false space or an artificial gravity and a big space station or of some sort that can travel across space and time, carrying with it many generations of our
Yes, and of course, every day new technologies are invented. For example, the space elevator that's coming soon could lead us to bringing massive spaceships into orbit, so we can send, for example, something quite big that would sustain maybe 100 people and could create artificial gravity. So then that leads us to saying goodbye. Thank you everyone for joining us on the SECA first meeting.